Beside of array list, we have also slice list. Slice list has many different characteristics in comparing with array list. Slice is also declared as variable. We will type reserved word var, then we will type name of that slice, and then we will specify declaration of slice and data type. In this case, we have slice list, and inside of that list we can put integers values. As you can see, inside of our brackets we didn't specify specific number like we did inside of our array list, because our slice list is resizable. We will create one more slice list as slice of strings. Beside of fact that we don't have final number for our size, we also have one thing. Our slice also has capacity. Built-in function make will help us with that. Function make will have three values which we need to pass, where first value is data type, second value is length, and third value is capacity. Let's now see how we can declare our slice. We will access specific slice, then we will call our make function, and now inside of our make function, first we will declare our data type, then we will write length. As you can see, we didn't specify third value, which is capacity. It's not necessary that we assign third value. In case if we didn't specify third value, that third value will be equal with our second, which means that in this case our length and capacity will be equal, and that value will be 10. When we specify capacity, code will look like this. So now our length is 10, but our capacity is 20. How we can check the length and the capacity of our slice list? We can print these two values with two different functions, like this. Function len will tell us length of our slice list. For capacity, we have also built-in function cap, which will give us capacity of our specific slice. Let's now see how we can assign specific values to our lists. In these two lists, we now assigned new lists with new values. What happens with our length and capacity of these two slices? As we can see, the length and the capacity of our slices has changed. Our slice will update our length and capacity according to our last update. Capacity is changed according to our length. Let's now see how we can add new elements inside of our slice list. When we work with slices, we can also write indexing for our specific slice, and we can also target specific elements inside of that slice with indexing place. Also, we can assign new updated value of specific slice to previous state of that exactly the same slice. Let's say we need to remove last element inside of our slice. In this case, our int slice will be updated with new value of int slice, where we will start from indexing place 0, which means we will start from number 4, and we want to reach place where indexing number is equal size of our int slice variable minus 1. This means that we want to reach the last index of our slice, but indexing won't count that element inside of our new updated slice, which means that with this indexing we removed last element. When we print our new updated slice, output will look like this. We want to know what happens with our length and capacity of our slice. We can see that length of our slice is 5, but capacity is 6. When we declared our slice, number of elements inside of that slice was 6. So when we remove specific elements, we updated our length, but capacity of that slice is still the same. Let's write another example. We want to update our str slice, and the new updated value will be new slice, where we want to start from indexing place 0 and we want to reach indexing place 1, which means that we will take only first element of our slice. Then when we print this list, we can see that we have inside only lion value. When we print length and capacity of this slice, we can see that capacity is still 3, but now length is 1. Now we want to know how we can add new elements inside of our slice lists. Built-in function append will help us with this. We will access our slice, then we will write our append function, and now we will have two groups. First group will be specific slice in which we want to add new values. So in this example will be the same slice. And after that we add new values which we want to add in that specific slice. For this example, we will add 3 new elements. Now, instead of 5, we have 8 elements inside of our slice. Let's now print length and the capacity of our slice. We can see that length of our slice has changed and now it's 8, but capacity is 12. How is that possible? With capacity, we must remember one thing. Each time when we breach the number of our capacity, that capacity is doubled. Previous capacity was 6, and when we add 3 new elements, now length is 8, which means that we breach our capacity. Immediately after that, our slice will double our capacity because capacity cannot be smaller than our length. Let's do another example. We add 6 new elements inside of our slice, which means that our new length will be 14. Our previous capacity was 12, which means that we again breach our capacity. Our slice will immediately double our capacity, and now capacity is 24. Let's now see what happens when we add new elements, but we don't breach our capacity. In this case, length was 1 and our capacity was 3. In this case, we add one new value, which means that we now have 2 elements inside of our slice. When we print our length and capacity, we can see that length is changed and now it's 2. But capacity is still the same because we didn't breach the value of our capacity, and that capacity in this case will remain 3. Next, we want to know how we can remove specific elements on specific index place inside of our slice. In this case, we have a new slice S with 10 new values. Now we want to remove element with value 5, which means that we want to remove index place 5, which in this case will be 6th element inside of our slice. We will access our slice, then we will execute our append function, and now we want to combine 2 different sub-slice inside of our S slice. For first element, we will write all elements from start to indexing place 5. This means that our starting point will be slice which have values of our S slice, starting from indexing place 0 to indexing place 5. But remember, in this case, we will skip indexing place 5 because we won't count that place. Next, we will add all other elements after indexing place 5. We will again access our s variable, and now inside of our brackets we want to start from indexing place 6 and we want to go until the end. We didn't specify specific values as separated elements inside of our append function, and we have a problem because this s, which is starting from indexing place 6, is not element, it's a slice. So how we can solve this? Our language provide for us one additional operator. After our brackets we can specify 3 dots like this. This means that each element inside of our slice will be added at our starting point. In final picture, we skipped place with indexing number 5 and then we again start from indexing place 6. After that, we will go until the end of that slice. Now, when we print new updated slice, the output will look like this. Let's create another example. We have a new slice of data type string with 3 new values. We want to remove value bill. That value has indexing place 1. We will access our variable, then we will call append function, then we will reach specific indexing place, but we won't count that place, like this. And then after that we will specify all other elements inside of that slice. Now when we print new updated slice, the output will look like this. We can see that our value bill is removed from our M slice. In the next video we will see how we can create and modify multidimensional slices.